How about this? It's something called the ultrasonic gripper. And I know you're going to look at that, Will. And you're going to say to yourself, what am I looking at? You're going to say to yourself, why is Lou putting this in front of me? Now, without scrolling any further, I want you to tell me what that thing does there, Will.
Lets robots move things without touching them. That's the title.
Yeah. That's you can't just read the title.
But looking at the image, it's very confusing.
I know.
Those two don't match. It's like two half domes, and then it's like there's something in the middle of it, in between, like water or something. Using ultrasonic pulses, it's able to concentrate the forces and be able to centralize the object in front of the domes.
Willie Einstein.
Right?
Willie Einstein. I nominate Willie Einstein.
That's a water droplet, right?
So
is that right?
It is using ultrasonic sound to create pressure on the inside of this cavity. Yes. For those of you that are just listening to this, it's got these two things that look like bowls. They look like cereal bowls, actually, probably for some alphabets later on.
They're like an inch away from each other?
They're like an inch away from each other, and they're facing one another. At least the cavity of each bowl is facing one another. They are able, through ultrasonic sound, to create a pressurized zone in there. That pressure is strong enough, capable enough, to actually hold a small object in the center of this contraption without anything physically touching it. The pressure itself. Now, the reason this is important is because sometimes, and for the record, you need to scroll down a little bit because you're sitting there thinking, what is that thing even holding up? If you head to the video, there's a video there, Magic Robot Hand. And if you scroll forward a little bit, you'll see that this little robot is holding up these almost microscopic, tiny little elements for a person working with incredible precision that would normally have nowhere to put that thing. Look how small that little fragment is. So we're talking about jewelers and watchmakers. Some other examples they gave us here. What do we got? Ultrasonic gripper customers could include watchmakers, where existing grippers can damage the thin film of lubricant on small components. Microchips seem like another potential use. So anything you can't really touch or manipulate, or if you used a physical thing to grip it, you might damage it. So you can imagine the potential precision applications for this. It's amazing. You just put it there, you know it's held there. You ever worked on something tiny, like opened up an iPhone or something? You put these little screws in. Oh my goodness gracious. And we're talking about objects potentially even tinier than the tiniest iPhone screw. And you need to reliably put somewhere and then move it around. And that's how this grip works. Kind of an unusual implementation of a robotic gripper or robot hand. You hear that and you think of something grabbing something large and like moving it or manipulating it. But this is some strange combination using ultrasonic sound. You never would have expected it, Will. In fact, if you look at those little black dots on the inside, you can see the kind of speaker modules in there. And yeah, right in there. It's kind of crazy what you can do with sound. You could probably, with enough of this, we could probably lift you up in the center of the studio.
Yeah.
Levitation, Willie do.
Just meditating.
That's interesting. Why doesn't that work? I guess you just had to be in some sort of contraption like that, life size. Here's to the next invention, I guess. Levitating do.
Very cool.